Hello everyone, welcome back for part 3 of the energy segment. So we talked about kinetic energy, which is the energy of movement. We talked about potential energy, which is stored energy based on height. And now we're going to talk about mechanical energy. What is mechanical energy? It's basically the link between potential and kinetic energy. Now, let me use the roller coaster as an example. When you take place in a roller coaster, you obviously have a thrilling time, but that's not what I want to talk about. I want to talk about the physics aspect of it. So when you go up a certain segment, as you're going up, your speed is decreasing, right? So your height is increasing, which means your EP, your potential energy, should be increasing, but your speed is decreasing. So that means your kinetic energy should be decreasing, right? So they're kind of going in the opposite way. You're slowing down, so your movement or your kinetic energy is decreasing, but your height is increasing, so the potential energy is increasing. Now, as you get to the top, now things start reversing as you go down towards the other side. So now you're accelerating. If you're accelerating, you have more movement. So your your kinetic energy would be increasing. Oops, sorry about that. Would be increasing. But because the roller coaster is going down, the height is decreasing. So that means your potential energy is decreasing. So you can see they're going in opposite directions. So really, there is a link to be made between potential and kinetic energies. And what is this link? Well, it's called mechanical energy. So mechanical energy links up the two. Mechanical energy is equal to potential plus kinetic energies. Okay, so they add up to form mechanical energy. And mechanical energy is always constant within a system. So if I look at my roller coaster, the mechanical energy involved in this situation will always be constant. The kinetic will change, the potential will change, but the total amount will remain the same. So it's just an exchange between kinetic and potential that's happening, but the sum of the two remains constant. Okay? So over here, what it shows is that potential transforms into kinetic and vice versa, depending on where you're at within the roller coaster. Okay, so we'll assume there's no friction. In other words, there's no outside situation or force influencing the system as if it's a pure situation, a perfect one. So kinetic transforms totally into potential and vice versa, depending on where in the roller coaster you are. Okay, so this is based on the law of conservation of energy. We're not destroying anything. We're not creating anything. We're just transforming the energy back and forth between potential and kinetic. Okay, they're just being converted into one another as the situation evolves. Now, if you have an object that is thrown up in the air, so you have a little illustration over here. So if you have an object that's thrown up in the air, well, the object will gain height until it reaches a maximum point, at which point the gravity force is too strong. The object can't continue going up. So it kind of stops for a millisecond, and then it starts coming back down. So when it's at the top and it stops, like it's so fast that you don't really see it stop, but when it stops, well, there's no more movement, right? So if there's no more movement, there's no more kinetic energy. So that means at that point, there's only potential energy and obviously mechanical energy. So we will say that EM, the mechanical energy, is equal to the potential energy for that very little moment where the object stops moving. Now, as the ball, let's say it's a ball, as the ball comes back down and basically is just about to touch the ground, so essentially its height is at 0, more or less. Well, if the height is at 0, there's no more potential energy. So when it's right near the ground, like right as it's touching the ground, if there's no more potential energy because there's no more height, what are we left with? We're left with kinetic energy and mechanical energy. So EM is equal to EK, right? As we have over here. Now we know that EM, the mechanical energy, never changes for a given situation. It is constant. So knowing this, it will allow us to solve various problems. Now, if I break down the equation into its variables, what I would have is EM is equal to mgh, because potential energy is mass times gravity times height, plus the kinetic part, which is half the mass, so half the mass times velocity squared. Okay, so if we have a complex problem that involves both types of energies, we know that they're both equal to EM, and that number is always constant, and we can break down each type of energy into their components, so mgh and 1/2 mv squared. So that's it for mechanical energy. As long as you remember that it's the sum of potential and kinetic, and that basically kinetic becomes potential and potential becomes kinetic as the situation evolves, that's all you need to know. The rest is all math application. So I hope this was clear. If you have questions, please reach out. And otherwise, I will see you around for your next lesson. Until then, take care.